Richart, we've already talked about collecting and heating water and its applications on your island. How do you cool down?
It's a good question because, well, you could just dive in the water, of course, and that usually works. But you don't always want to get wet, And at night, when you're sweating in bed, you kind of want an air conditioning unit, don't you? But we know that they're fairly unecological. If everybody on the planet has one, then would be more in the.
So how do you get around it?
The carbon footprint was bigger and bigger, right?
Of course.
So, okay, I'm going to explain it. I came across this idea from seeing one of the holes where I plunged more bottles under through the hatchways, where I had them and the roots attached to the bag, automatically. When a boat would pass and give some waves that were decent size, and it came through the island. So if you've got the island like here, and let's say you have a hole somewhere in the middle, near the middle, the level of the water is there, kind of thing. If a set of waves come in here, when that wave comes here, this edge lifts up, but it keeps on going through the island. So if you were stood here and you're looking at that wave come in, you will actually see if a tree is here, that tree will rise and then fall, and then if there's another tree, that one will rise and fall. You see the wave coming in, and when it gets to the middle, because there's not much weight on the outside, the whole island just follows the contour of the wave. It breaks it a little bit, but when it comes into the middle, and I had a house and bigger trees and things like that on it, there was more weight. So the wave is going to find more difficulty in lifting the island here. So what happens is that water level goes up and down in that hole. So let's do a bigger, closer drawing now. So we've got a hole here. Let's say that's the water level. That water level goes up and down. It can be a meter or more, depending if you're on the ocean with the island.
That depend on the size of the island or the waves?
Size of the island and the size of the waves that you can get on.
Right.
I mean, once we've got a bigger island, you can go on more of a choppy water. And the edge of the island breaks it a little bit, but the swell goes through. So it lifts and falls, the water here. The island will lift on the wave to some degree, but because there's more weight on it and things here in the middle, there's more resistance to the wave, so the wave comes up down, up down. So my idea was to put some sort of a table over the top, so I'm going to make it look like it's see-through right now, but it could be a glass table as well, so you could have it as a glass table on top. It'd be super cool. So now you're looking through the glass table, it's all sealed. So now when the first wave comes, it's going to blow the top of the table off, isn't it? Unless you have it really well bolted on.
Of course.
It's just going to boom. So I'm like, okay, that's pressure inside there, right? So my idea was this. So because you've got the trees here with the roots coming through the base and all the bottles inside there, all the way around, maybe 2 meters deep or more even. And because the bottles are angling back like this, it's actually like a cone underneath. So the wave is like concentrated in there and comes up even more high. Okay. So my idea was to have a cloth hanging here all the way around, thick, durable cloth, to act as a valve. So behind that cloth is the roots and the plastic bottles. And that cloth goes deeper than the water level when it's on its lowest level. So now the wave is down, it's down to that lowest level. The cloth is a little bit further, so it's trying to suck air in because there's now a vacuum where the wave goes down. So that cloth lifts up and it sucks air into this chamber. The cloth can be in parts, like with gaps, it overlapped a bit. So that one cloth can lift up and then air can come from between the roots and the bottles into here. Now that air will be cool.
Of course, because the sun's not getting to it.
It's above the water level, so it's kind of dry. It's dry air that's coming in, dry-ish. It might be a little bit moist. It'll come into that chamber, cool, and then when the wave comes back up, my idea was to, let's say we just draw it here, have a pipe coming out here with a valve on it. So this has got a doorway that can open just this way, open this way. So it lets air out, but it won't let air in.
Okay.
And that's a pipe coming off. A pretty big wide pipe, let's say. Maybe about that wide.
Okay.
Coming off that chamber. And you could have an actual spiral.
Oh, like insulated ducting.
No, well it would be. It would be insulated ducting. It would be cool air coming through here. But what I'm trying to draw like a kind of a corkscrew thing inside there that fits. I mean, obviously this is an engineering. It would have to be done, but it could definitely work because it'll be a strong boost. That whole wave, the strength of it, will be big, and you could have that spinning, and that could be a turbine creating electricity, charging up batteries.
Oh, okay.
Or creating DC current or whatever. So that could actually be creating power, but it wouldn't stop the air, so the air still go through. So that will then split.
So do you mean
into little
when
pipes.
you say this coil? Do you mean like a series of fans that are almost acting like dynamos?
Yeah, like a fan inside, but I envision it as like instead of it just being one fan. But you can do it in many ways. Yeah, of course. It's something that turns with the air passing.
Oh,
so that turns.
Right, so the whole
it's a dynamo, and it's
right. So you
creating,
mean
it's like a windmill. You know, you have a windmill that turns with the wind. It's a windmill inside a tube.
brilliant?
A wind turbine creating electricity inside that tube. Now the cool air continues. You've got your electricity here, your batteries here, whatever. So you've got power. So this is a wave-powered electric charger and air condition unit. So you've not only got an air condition unit, but it creates electricity. It doesn't cost. There's no electricity being used. It's actually producing electricity.
You can charge
So
your phone off.
laying in bed. That's day and night by waves.
Yeah, of course.
You could charge your phone off that. Of course, you could run your fridge off it. You know, so you're not only getting cool in night in bed, but you got your drinks cool in there as well, you know. So these tubes can split off into smaller ones. That one goes in one room, and all you have is like a fluffy ball. It sticks in the end. So if you're laying in bed here, you know, you want. Well, I'm drawing it pretty crudely, but I mean that can come out the side of the wall very neatly, or you can have it where you move it and it's just blowing wafts of air onto your face or wherever you want it, you know. And then if you don't want it and it's a cool enough night, you just stuff that fluffy ball in there like a pom-pom. And nothing comes out, it comes out the others. Obviously, if everybody stuck the fluffy ball in, they might all pop out. But you could have some fun with that, couldn't you?
Of course. That's excellent. Thank you very much, mate.